Ito common to sa board exam. Pero, more on substitution na lang siya guys, no? Good day everyone. So, our topic for today is about stress distribution. Actually, may nag-comment guys na may nag-request na italakay natin yung Boussinesq equation and yung Westergaard equation. And yung isa pala is 2:1 method, which is italakay ko na lang for my next video. So, for today, about stress distribution tayo guys. So, ito common to sa board exam. Pero, more on substitution na lang siya guys, no? More or less, given naman yung formula na gagamitin. So, una tayo sa Boussinesq equation. So, for concentrated load, ang dinidiscuss about the stress distribution. For example, may load dito guys. Ayan, may load. Linear load. Ayan. May stress na may experience yung soil. Most probably, pinakamataas na stress is the surface of the soil na nasa baba mismo ng load. Pero, dito sa point na to, meron pa ding stress na na-experience itong point na to. Okay, tama guys? For example, dito, sa stress na to, sa point na to, may mas mataas na stress na may experience ito kaysa dito kasi mas malapit siya sa loadings. Ayan guys, yung topic natin. For stress distribution, inaalam natin or ina-approximate natin kung ano yung natatanggap na stress sa isang particular part ng soil based sa loadings na given. Gets guys? So, dito tayo sa Boussinesq equation. So, may drawing siya guys, no? For example, point load. Hinahanap dito yung stress. Sabihin natin, this is point A. Yan ang point 8 guys. Hanapin yung stress given na may vertical distance Z and horizontal distance R. Ayan guys. So, meron siyang mga formula guys. So, this is the formula for the point load. This is the formula for a uniform load or line load. So, ano yung change in P? The stress increase. Ito guys yung stress na experience sa particular point under the soil. And guys, so Z is the vertical distance, R the horizontal distance, P is the point load, and Q is the line load. So ito guys yung sinaulo kong formula during my review. Kung baka nagbabaka sakali ako if ever na hindi mabigay yung formula during the board exam. So madali lang siya guys, no? 3p Z cube all over 2 pi times the quantity of Z squared plus R squared raised to 5 halves or 2.5. So ito yung sa uniform load. So, ayan guys. Pero, makikita natin sa internet na meron isang formula. Ito yung isang formula guys. 3p over 2 pi z squared. Kung titingnan mo parang magkaiba siya guys, no? Pero, parehas lang yan. Kung ano man ang gusto mong isaulo, pwede ito, pwede ito. Ito, for point load siya guys. So, pwedeng itong sauluhin mo, pwede din ito. Same naman yung sagot na makukuha mo. And guys, so, mabalik tayo guys, no? Maaring ang given, for example, ayan, i-3D natin siya guys, no? Ayan. Kita ba guys? Example ito. Nandito yung point load. Ayan. Tapos, pinapahanap yung point na nasa baba nito. Meron pa ditong X and Y. Sabihin natin X and Y. Tapos, ito yung Z niya guys. And guys, so therefore, ano yung niya? Horizontal distance. Hindi yung X, hindi yung Y. Ano? So therefore, ito, horizontal distance. Nasa isang plane siya guys. Na-imagine ba guys? Ito isang plane. So yung horizontal distance is the R. So paano makuha to? Since it is a right triangle, ito ang X. So this is the hypotenuse. So pwede mo siyang makuha, no guys? Hanapin mo lang yung resultant, x squared plus y squared is equal to r. Ito na yung gagamitin mo na horizontal distance for the computation of the stress beneath the for example itong point A. Ayan. So pwedeng ang given ang given sa problem is the x and y guys, no? So be careful lang kung ano ba talaga yung given, kung horizontal distance ba or ganito guys. Bali, imaginin nyo na lang kung ano ba yung given sa problem. So, next tayo guys. Westergaard equation. Bali sa Westergaard equation, sa mga CE refs, usually ito yung lumalabas. So, meron tayong isang equation about the point load which is 0.318 Qn over Z squared. Ano nga ba yung Q? Yung Q guys na ginamit is yung point load. Same lang siya guys sa P. So, ang N, sabi dito is 1 all over the quantity of 1 plus 2 times R over Z squared raised to 1.5. So, parang kakaiba guys, no? Pero, same lang yan. 1 divided by pi, try natin guys, 1 divided by pi is simply 0.318. Kita ba guys? So, therefore, this two equation is similar. And guys, so ako, preferred ko, ito na lang yung sinaulang. And guys, so let's try an example guys about the Boussinesq equation and the Westergaard equation. So here we have one problem. Sabi dito, evaluate the vertical stress in kilopascal at a point below the ground for a point load which is 1,500 kilonewton if the point is 2 meters directly below the point of application of the load. So let's try guys, sa Boussinesq equation muna tayo, BE. So ano nga ba yung formula? Change in P is equal to 3pz cube over 2 pi z squared plus r squared 5 over 2. And guys, so given tayo ng 2 meters directly below, so meron tayong z is equal to 2. Pero, walang sinabing horizontal distance. So, ang R natin is 0. So, ang point load natin is 1,500. So, the direct substitution siya guys, no? So, let's try. 3 times 1,500 times 2 cube 2 times pi times 2 squared plus 0 squared raised to 2.5. Bale, 179 kPa. Ito guys yung sa Boussinesq equation. How about guys the Westergaard equation? So sabi natin change in P is equal to 0.318 Qn over Z squared, wherein N is equal to 1 over 1 plus 2 R over Z squared 1.5. Guys, so diretso na tayo guys, no? So hanapin na muna natin yung N. 1 over quantity of 1 plus 2 times R over Z. Ano yung R natin? 0 guys, no? 0 over 2, squared natin to, tapos ito 1.5. So, 1 ang N natin guys. So, dito naman tayo, 0.318 times Q, which is 1,500, times ang N natin guys is 1, Z squared is 2 squared. Bale, in terms of Westergaard equation, meron tayong 119.25 kilopascal. And guys, so magkaiba siya guys, no? So, sa board exam, kung ano yung hinahanap, for example, use Westergaard equation, ito yung gagamitin natin guys. So, dito tayo guys sa second. The point is 4 meters below but 2 meters horizontally from the application of the load. So, ang approach na gagawin ko guys is the Boussinesq equation na lang guys, no? So, try nyo na lang i-solve sa Westergaard equation. So, 3 times 1,500 times, ano daw yung Z guys? 4 meters pa din. 4 cube. 2 times pi times the quantity of 4 squared plus horizontally. So, therefore, this is exactly Z. So, 2 squared na siya guys, no? Raised to 2.5 or 5 halves. So, the answer would be 25.623 kilopascal. And guys, so this is for A, ito yung B. Hindi ko na i-compute for Westergaard equation mo guys since direct substitution naman. So, for example, here we have a problem wherein meron siyang 2-point load guys, no? So, hinahanap yung stress na ma-receive nitong dalawang point load dito sa point A. So, paano nga ba to guys? Bale, ang approach dapat na maisip nyo is i-add lang yung dalawa, which is correct. So, therefore, let's try the Boussinesq equation lang guys, no? Assignment nyo na lang yung Westergaard equation in this problem. So, diretso calculate natin guys, no? So, 3 times what is the load? 470. So, 470 times Z squared, which is, 2.5. 2.5 cube pala guys, no? So, 2 pi times 2.5 squared, tapos ito 1.2 plus 1.2 squared raised to 5 halves, which is 2.5. I-add na natin guys, no, yung isa. So, 3 times, ano yung point load naman? 350 kilonewton. 350 times Z squared, parehas silang Z squared. Z cube, parehas silang Z, times 2 pi times 2.5 squared plus, ano naman? 2.4 squared raised to 2.5. And guys, so the stress na nare-receive ng point at point A is 26.605 kilopascal. Ayun guys. So, bale, based sa dalawang point load, yung stress na na-receive at a particular point, which is the point A, ito yung 26.605. Inad lang natin guys, yung point load nito. And guys, thank you so much.